Today's video will be on applying trigonometry. Our lesson goals for today: by the end of the lesson you'll be able to calculate angles of elevation, calculate angles of depression, and apply trigonometry to solve real-world problems. Okay, so we've got some key ideas here. So these are the 4 steps that you need to take when you're using trigonometry to solve problems. So to solve application problems involving trigonometry, follow the steps. So the first is to draw a diagram and label the key information. I can't stress how important it is, especially in trigonometry, to draw diagrams and label them. It makes it so much easier to see what the question's asking you to calculate and see what you need to do to answer the question. Once you've done that, drawn your diagram, you can identify and draw the appropriate right-angled triangle separately. So once you've drawn your diagram, it becomes clear what you're being asked to do, and from there you can draw the right-angled triangle, and that will help you solve the problem. The third step is solve using trigonometry to find the missing measurements. So that could be an angle, it could be a side length, it could be anything like that. And the last one, which is also very important for your communication, is to express your answer in words. Remember, if you're asked a question, like a worded question, make sure your answer is also in words. Okay, so just a few things to note before we go on about angles of elevation and angles of depression. So if we look here on the diagram, we've got 2 points. So we've got P, which is the point that you're looking from. So P is where you are looking, and Q is where you're looking to. The other important thing is the horizon. So the horizon will come straight out from your point of view. So if you are in line with the horizon at point P and Q is up above you, so you're looking up at Q, that is called an angle of elevation. On the other hand, if you're at P, which is the point that you're looking for, the horizon's obviously out in front of you and you're looking down to see Q, that's called an angle of depression. So that's the difference between those two. And angles of elevation and angles of depression are always measured from the horizon. So going from that straight out from where you're looking from, that angle would be your angle of elevation, that angle there would be your angle of depression. So you're always measuring from the horizon, either up for an angle of elevation or down for an angle of depression. You can also see here something that we've touched on before. If you've got 2 parallel lines and you're cutting them there, the angle here and this angle here, they're going to be equal because alternate angles in parallel lines are going to be equal. So the angle of elevation from B from A, so if you're at A here, this would be the horizon and you're looking up at B, so that's an angle of elevation. So I'll draw that in purple. So this is your angle of elevation because this would be P, this would be Q, and this is your horizon. So that angle of elevation is going to be equal to the angle of depression. So if you swap that around and you now have P here and you're looking down at Q and this is now your horizon, that angle would also be the same. So those are equal alternate angles there. So that could be useful for some of these questions. Okay, so worked example. Our first one here. So the angle of elevation of the top of a tower from a point on the ground 30 meters away from the base of the tower is 28 degrees. So find the height of the tower to the nearest meter. So this is where you really need to start drawing those diagrams. So you have a tower here, and so the angle of elevation of the top of the tower from a point on the ground 30 meters away. So you're 30 meters away from the tower. So this here is 30 meters, and the angle from 30 meters away to the base of the tower is 28 degrees. Okay, so going up like this, and this one here is 28 degrees. So you can see I've got a right angle triangle here from the ground to your tower there, and we need to find the height of the tower. So the height of this tower in meters, so find the height of the tower to the nearest meter. So there we go. We've got a right angle triangle. You can see that we've got some of the sides and an angle there. So we can use our trigonometry to solve this. If you want to label the sides, you can. So you've got your hypotenuse, you've got your adjacent and your opposite there. So we're dealing with opposite and adjacent sides, obviously, because we want to find out the value of our opposite side and we're given the value of our adjacent side. So according to our SOHCAHTOA, we're dealing with tan because we're given the opposite over the adjacent. So as we know, tan of an angle, which is 28 degrees, is going to be our opposite, which is our height, over our adjacent, which is 30. And from there, you can solve. So that will be our height is equal to 30 times tan 28. You can put that into your calculator there. So 30 times tan 28. So it's 15. I'll grab my pen again. So the height will equal 15.9512 blah 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 blah, but our question asks us to round to the nearest meter, so that's obviously 16 meters. So our last step when we're doing our problem solving is to answer in words. So therefore the tower is 16 meters high, and that's rounded to the nearest meter. And that's all you have to do. Okay, so we've got another worked example. So our second worked example, from the top of a vertical cliff, so we've got a vertical cliff, so that's straight up and down, so vertical, there we go. Andrea spots a boat out at sea. So if the top of the cliff is 42 meters above sea level, so that's 42 meters, so from the bottom of the cliff to the top, 42 meters, and the boat is 90 meters away from the base of the cliff, so 90 meters away from the base of the cliff. So we've got a right angle there because it's a vertical cliff, so you can start to see there where our right angle triangle comes into play. Find Andrea's angle of depression to the boat to the nearest degree. Okay, so Andrea is sitting up here on the top of the cliff, and we've got our little sailboat down here. Now, it says the angle of depression. So the horizon would obviously be coming out like this because it's straight out from where Andrea is seeing. And our angle of depression is going to be this unknown angle here. Now, you're probably thinking, oh no, but that's not part of our right angle triangle. But remember, this line is going to be parallel, a horizon line is going to be parallel to our sea level there. And we know that those alternate angles of parallel lines are going to be equal. So it's actually going to be equal to this angle here. So if we can calculate this angle down the bottom here, it's going to be equal to the angle of depression up there from where Andrea is. Okay, so if we look at this, we've got our hypotenuse, we've got our adjacent, and we've got our opposite sides. So again, we're going to be dealing with tan. So tan of an angle is equal to our opposite over our adjacent, so we can fill that in. So that's 42 over 90. But we want to find what the angle is, so we're going to have to use our negative indices here. So our angle is going to equal, sorry, no, negative indices, our inverse operations, ignore that. So we're going to find our inverse of tan. So the inverse of tan, 42 over 90, will give us that unknown angle there. So we can use our calculators. So I realized in my last video it wasn't clear where I pressed. So second function, tan, and you can type it in. So you can use your fraction button here. So 42 over 90, close brackets. Okay, and that is 25.0168 blah 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 blah, but the question asks us to find it to the nearest degree, so we'll round that to 25 degrees, and because those angles because alternate angles in parallel lines are equal, the angle of depression will also equal 25 degrees. I've run out of space. Angle of depression will also be 25 degrees. Yours will be set out a lot neater than mine. And obviously the last little bit would be to answer the question, which you would do below what you've just written. I'm just going to have to do in this box here. Therefore, Andrea's angle of depression to the boat is 25 degrees to the nearest degree. Okay, and that's that question there. Okay, so our last question here says a plane is flying at an altitude of 1,500 meters. Okay, so from the ground this is, so we've got our ground along here, and our plane is up here flying at 1,500 meters. So you can see I'm starting to draw the picture. So let's draw, ooh, how on earth do you draw a plane? That's its wings maybe? Ooh, does that look like a plane? It kind of looks like a butterfly. Okay, that's a plane, not a butterfly. Anyway, my plane is 1,500 meters from the ground. And it starts to climb at an angle of 15 degrees to the horizontal. So that's 15 degrees off the ground. So from the ground, like from its horizontal to the ground, it's starting to climb 15 degrees. So that's this angle here. It's 15 degrees. When the pilot sees a mountain peak 2,120 meters high, 2,400 meters away from him horizontally. Okay, so that's a lot of information. So it's saying 2,400 meters away from him, he sees a mountain peak which is 2,120 meters high. So that's how high the mountain is. Okay, so will the pilot clear the mountain? So if he continues to fly at this 15-degree angle from 2,400 meters away from the mountain, will he clear it? So we know that the mountain is 2,120 meters high. He is already 1,500 meters off the ground. So if we take that away, so if we take away how high he is already from the height of the mountain, we'll see how much extra he has to climb to clear the mountain. So 2,120, which is the height of the mountain, take the distance he already is from the ground. So he's got 620 meters to clear. And we want to know this mystery amount here. So if he keeps climbing at 15 degrees for the next 2,400 meters, will he actually climb high enough to clear this mountain? So pretty much if we work out x and it's greater than 620 meters, we'll know that he'll be able to clear the mountain. So we're looking at that. We've got another right angle triangle here. We've got an angle. And we've got each of the sides. So this would be our hypotenuse, this is our adjacent, and this is our opposite. So we're trying to work out the value of the opposite side, and we've got information on the adjacent. So we know that using SOHCAHTOA, we obviously have to use tan. So tan 15, because that's the amount he's climbing, is equal to our opposite over our adjacent. So tan 15 is equal to x over 2,400. So then we can just rearrange that. So x equals 2,400 times tan 15. Put that into our calculator. So 2,400 times tan 15. That equals 643. I'll round to 2 decimal places, so it's 0.78, so I'll round that to 0.8 meters. So if he keeps climbing at that 15-degree amount, he will climb a total of 643 meters. We know he only had to go an extra 620 to clear the mountain, so therefore he will clear the mountain. So therefore, the pilot will clear the mountain as she will climb 643.08 meters and the mountain only has 620 meters left for her to climb. Okay, so that didn't really make sense. The mountain's not 620 meters tall. Obviously, the mountain was 2,120 meters tall, but she was already 1,500 meters tall in the sky. So working out that distance there. Hopefully that's clear. Also, I just realized my pilot changed gender from a he to a she. Doesn't really matter. Hopefully you can see how to apply trigonometry. As long as you keep those basics, so the 4 rules, so draw a diagram and label it as you need to. As you can see, you don't have to be great at drawing. As you can see by my my plane cross butterfly creation there. Doesn't matter. As long as you're drawing a diagram and labeling it, actually things become a lot clearer. The next thing you have to do is identify the right angled triangle, and you can draw it separately. So I have drawn on my diagram the planes and the ships and the people. You can just draw your triangle separately from that diagram if you need to. Next, you have to solve using trigonometry, and the last thing obviously is write your worded answer. So just remember those 4 steps and really apply that to every worded question for trigonometry, and it'll become a lot clearer. I know I've said it like a million times already, rounded to the nearest million, but please, please, please draw a diagram and label it. It makes these types of questions so much easier, and it also helps me as well because I can see if you've kind of grasped what the question is asking you. And that's the end of today's video.